Hello, I'm Dr. April Grothe, and today we're going to be talking about reliability. Last week we talked about computer-aided text analysis, and we're actually going to just touch base on that just a little bit this week. Today we are going to be talking about reliability, the different types of reliability, and we're going to be talking about percent agreement and Krippendorff's alpha, which are in fact a way to measure reliability. And we're going to be utilizing a program called RStudio to, in fact, measure reliability on some coded data that we have. Reliability. An analyst demonstrates the trustworthiness of their data by measuring the reliability of it. So we have three types here. Stability. That is measured as to the extent to which a coding procedure yields the same results on repeated trial. It's a test-retest. One person does the test and they do the retest. It is in fact the weakest form of reliability. Replicability. That is the degree to which a process can be reproduced by a different analyst working under varying conditions. So maybe they're working in a different location, maybe they use a different, say, CADA program in order to get their measurements. Maybe they use a different calculation for reliability, but overall you have one person testing and then you have a different person testing. So we have test. And lastly, we have accuracy, and that is the degree to which a process conforms to its specifications. And we are comparing the performance of one data-making process or procedure with the performance of a procedure that is known to be correct. So this one, we're testing it and we're measuring it against the standard. So we have test standard, and this is in fact the strongest reliability test that we have available. So percent agreement. It is a measure of whether the categories are matching or not matching. And it actually does have some flaws here. It is limited to 2 observers, so you can't have more than 2 observers, or the results don't quite cope with that. Also, the metrics needs to be in nominal format, and we'll discuss that on the next slide. And it doesn't actually tell us anything when the reliability is absent. So there's a few flaws with this. There are other measurements out there for reliability, such as kappa, which is based on modifying percent agreement. But overall, what we talk about next, Krippendorff alpha, is in fact the best form. So Krippendorff's alpha, it allows uniform reliability standards to be applied to a great diversity of data. So it covers these flaws that we saw over in percent agreement. It works for more than 2 observers, and it works for different metrics. In fact, I have a bunch of different metrics listed right there. And it does, in fact, tell you things when reliability is absent. So these are, Dr. Krippendorff here actually developed alpha to help with these flaws from our percent agreement. So we have different metrics that we can use for for measuring our reliability. So they're all called alpha. They're either alpha nominal, ordinal, interval, ratio, or binary. So nominal, what is nominal? Nominal is numerical values that are treated as unordered names, and mismatching shows really no degrees. So you're talking about numbers on jerseys, things like that. That's more of a nominal data. Ordinal data, we have values that are ranked 1, 2, 3, 4, 5, etc. And the differences are a function of how many ranks are between any of the 2 of them. So that's for ordinal. Interval is numerical values that are understood as the points on an equal interval scale. So you have an interval scale 1 through 5, and these are points on that interval scale. Ratio, this is the difference between 2 values that matter only in relation to how remote they are from 0. So in fact, the difference between smaller values weighs more than that same difference between larger values, because those smaller values are closer to 0. And lastly, we have binary data. So this one, the observer assigns one of two values, which usually we're talking about 0 and 1, but one of two values, and you use a different alpha equation for that. So as you can see, there's a lot of different options here for measuring our reliability using Krippendorff's alpha. So now let's talk about RStudio. So first, we have data sets that we utilized with our RStudio, and these data sets were generated when raters visited 20 hotels and then coded the quality of those rooms using a supplied codebook and categories of 1 through 6, with 1 being the room is unacceptable and 6 being it's just an outstanding room. And those are the values they came up with. And we have two different data sets here, one with 3 raters and one with 5 raters. So you download RStudio. It's pretty easy. You can actually Google RStudio and it'll come up for you. So how you want to input these data sets, we have the 3-rater data set, and this one actually shows the 5-rater data set here. So RStudio is going to show up, and it's going to come up with these 3 boxes here, 1, 2, and this 3rd box. This upper left-hand box here is because I have already inputted the 3-rater data. It only shows up after you input the data. So you're going to go over here to import database. You're going to choose from a text file. Then you're going to get a pop-up box that asks you which file you want. You pick your file and you hit OK. Then it's going to come up with this import dataset box, and then you're going to give it some variables. For us, we wanted headings here. So these headings here, rater 1, 2, 3, 4, 5, we wanted the headings, so we hit yes. We wanted commas for separating them, so you can see that there's actually commas here. So those are really the only thing I changed was the yes. The rest of these, in fact, were just fine. So then it actually got cut off here, so I apologize for that. There's a little OK button here. You hit OK. This box goes away, and then you have, boom, here's your data set, and it shows up. And so this is the 3-rater data set, and another tab will show up here when the 5-rater data set, when I hit OK for the 5-rater data set. So pretty simple for opening the text up. So next, I wanted to get what Krippendorff's alpha and what the % agreement actual reliabilities were. So you put in a code, you go down to that bottom left-hand box and you put in a code, Krippendorff alpha code, and then remember I talked about the different matrices. So here in this data we're actually using an interval matrix, so that's why I typed in interval. If you were using a nominal or an ordinal, you would type in the different matrix code or ratio that you would want there. So interval, that's the data we have, so I typed in interval here. And here it comes up with our alpha score. It's actually a little low. Alpha is between 0 and 1. Rare occasion that it can get to negative, is it can especially get to negative if you use the wrong matrices, but here it's actually kind of low. If you're talking about 0 to 1, you're talking about 16% reliable here in our data. Next, we wanted to know the % agreement. So pretty simple here. We put in the agreement code, so agreement, and then our data set was called 3-rater data set. So typed in 3-rater, and it comes up with a % agreement code of 0. Again, this is where we talk about a little bit flawed here. It's not a 0. There is, in fact, some agreement for our data. It shows right here, 16% agreement. So it's not actually 0, but that's what we got here from our % agreement. And this is, of course, for the 3-rater data set. A little bit different here on the 5. We got a little bit higher on our Krippendorff alpha, 57%. And our % agreement actually does rate a little higher too. Still does not match, but we're getting closer here. So pretty simple. Like I said, you put in these codes. Interval for us, and again, the reason why I chose interval, if you remember, interval is numerical values that are understood as points on an equal interval scale. So our interval scale is 1 through 6, and the values you can pick are 1, 2, 3, 4, 5, or 6. That's it. Those are the only options. So we have an interval scale. That's why I used the interval alpha coding. So next, I want an actual summary of our raters. Why is it that our reliability here is a little low on both the Krippendorff and the % alpha? So here, I got a summary on raters 1, 2, and 3. It gives us the median value, the mean value, the minimum and the maximum, as well as our first and third quarters. And just looking at this, I can already say that there might be a questionable, unreliable coder here, because look at this mean. It is not the same as these. These are both 3, this one's 2. And our median also, look at our median is not the same too. And our mean also is a little lower too. So overall, I'm a little questionable here on 3. On here, in our 5-rater data set, we actually have a median that's the same all across the board, which is great. That actually does show me that there is a little bit more reliability. And if we look at our means, we actually have the same mean here between 1, 2, and 4, and different but the same mean for 3 and 5. So I wanted to actually see this in a different format, in a plotted format, to get a better idea again of, do we have an unreliable coder? So I apologize, I did not put in here the code for you to type in, but it's pretty easy. It's pretty much the same code as it was for our agreement, except instead of agreement you write box plot. So you write box plot and then you put the 3-rater data. And it comes up in the actual RStudio, and then I exported it. So I exported it just so we can have this graph. So it will actually show up in your RStudio in that bottom right hand box. This little plot will show up. So again, here on a box plot, let me just explain a box plot for you first. So all those values that we talked about on that summary are here in this box plot. So we have the median here, which is in fact called Q2, which is this line here, this nice thick line in the middle. Then we have our first quarter and our third quarter, and these are actually called little whiskers here, and the top line and the bottom line are the top and bottom values that are in this data set. And here actually, if we look down at the 5, we have a little dot here. This just shows an outlier. It shows that rater number 2 only picked 6 one time. All the rest of the data, in fact, fell into this box plot. So again, we talked about that the median was the same here for these 2, but it was very different for 3, and yet it was the same here for these guys. And the boxes, in fact, are a little different to show where our averages, our average data amount shows up in, but we have the same median. So I really do think that rater number 3 here in our 3 data set is in fact an unreliable coder. So here we go, we have our reliability data set for our 3 datas. So, and that was actually pretty easy. And again, talking about last week with the CADA, with our computer aided text analysis, this is where our computer can help you. Our computer, I think this took me, admittedly it took a few minutes to get it all downloaded and to get the data set uploaded, but once I got the data set uploaded in there, it was probably 5 minutes to have the results. And the actual Krippendorf alpha, I'm sorry I didn't actually put out the formula. It's a pretty long formula, and doing it by hand would be extensive and way more than 5 minutes just for one data set. So here we go, 5 minutes, and we got all this information, the Krippendorf alpha, the percent agreements, we got the summary, and the box plot. Pretty simple. Gotta love computers. So let's recap here. Today we talked about the reliability, and we talked about the different types, stability, replicability, gonna have trouble with that word every time, and accuracy. And we talked about percent agreement, which is measuring whether the categories are matching or not. And then we talked about Krippendorf's alpha, which is really our best, most uniform reliability standard to be applied to the great diversities of data sets out there. And we did talk about the different metrics. So what I'd like you to remember is that Krippendorf's alpha really is the best way to measure reliability of content analysis. And again, computers can really help us aid us in our analyses and just make things quicker. So I'd like to thank you for taking the time for listening. I hope you enjoyed this presentation of reliability. And is there any questions?